So let's solve first these three questions of PET scan. It's a very small topic. Sometimes the questions are mixed from any other topic. The positron emission tomography, PET scanning, obtains diagnostic information from a person. The information is used to form an image. PET scanning uses a tracer. What is meant by tracer? It's a radioactive substance which is introduced into body and absorbed by the tissues to be studied. You can say radioactive substance, you can say radioactive material. What? Introduced into body and absorbed by tissues to be studied. Radioactive substance detect which is introduced into body and absorbed by the tissues to be studied. PET scanning involves annihilation. What is meant by annihilation? When a particle interacts with its antiparticle, their mass changes into energy in the form of gamma ray photons. When a particle interacts or meets with its antiparticle, their mass changes into energy in the form of pair of gamma rays, gamma ray photons. State the name or names of the particles involved in the annihilation process: electron and positron. Electron and positron, they change. Calculate the total energy released in one annihilation process. So total mean the two masses, mass of electron and mass of positron, which are same. Einstein's equation says E is equals to mc squared. So you will say 2me c squared. Me is mass of electron, c is the speed of light in free space, 2 because 2 of the particles. So it is 2. Mass of electron is 9.11 10 power negative 31. C is speed of light 3.0 into 10 power 8 whole square. It should be the same number last time we tried to solve. 10 power 1.64 10 power negative 13 joules. Calculate the wavelength of each of the gamma ray photons. Actually, this is from quantum physics. So if you have the energies, hc over lambda is the energy. Energy is hc over lambda. You need each gamma, so you will use half of the energy. So you can rearrange to find the wavelength. So cross multiply, so lambda will be 2hc over energy. 2. H is Planck's constant. You can take from the sheet. 1.38 10 power negative 34. Just check it out in the books. 6.63, sorry. 10 power negative C is 3 into 10 power 8 over E, 1.64, 10 power negative 13. Please calculate it. Minus 38, minus 12 meters. This equation is from quantum physics, actually. The energy of a photon is hc over lambda. I did half of that because that was for 2 gamma ray photons. Yeah? Next question. Question 2. The positron emission tomography involves the detection of gamma radiations in order to identify position of origin of positrons in the body. The positrons are not naturally present in the body. How these positrons come to be present in the body during the PET scan? All it starts from the tracer. Yes, my dear students. So first of all, tracer is introduced into the body. Yeah, tracer undergoes beta positive emission. Which is positron emission. So they ask us how they are present in the body. So tracer is introduced, and tracer undergoes beta positive decay. Explain how positrons cause the emission of gamma radiation from the body during the PET scan. Certainly, annihilation process. Okay. So what happens? The beta positive, which is the positron, they interact with the electrons in the tissues. Yes. So this causes annihilation process. What happens in annihilation process? The mass of these two particles, it changes into energy. This energy is emitted in the form of pair of gamma rays in opposite direction. You need to write all these points. Positrons interact with electrons in the cells, right? Annihilation process takes place. Spellings ANNIHILATION. Annihilation process takes place. Mass of the two particles changes into energy, which is emitted as pair of gamma ray photons in opposite directions. Yes, you can write in opposite direction. So this is actually that. So all it starts with the tracer. It is introduced into the body. It goes for beta positive decay. This positron, it interacts with the electrons. Annihilation process takes place. What happens? The mass changes into energy. This energy is emitted in the form of pair of gamma ray photons. Show that the wavelength of gamma radiation detected by PET scanning is approximately 2.4 picometer. Exactly the same answer. You have to first find the energy like you did, and then use that energy you can find. So first of all, the energy of annihilation is 2 MeC square to 9.11 10 power minus 31 C. What was the answer on previous page? Just give me. Joules. Then write for each photon. The energy is hc over lambda. So since it's half, so lambda is 2hc over E. Okay. 2. It's 4 marks, so it's important to show the steps. So 2H was 6.63, 10 power negative 34. C was 3 into 10 power 8 over E, 1.64 into 10 power negative 13. What was that answer? Minus 12 meters. You want pico. So pico is, so divide by 10 power minus 12. It is 2.43 picometers, which is 2.4 picometers. So they asked us to show, and we showed. Explain your working. Yeah, we need to write just for each photon. This is energy of annihilation process. When they say explain just these two underlined words, you just need to write them, my dear. 2 more questions, and then we will start the astronomy. Make sense? Okay, students? Fluorine 918 is a radioactive nuclide that is used as a tracer in positron emission tomography, PET scanning. Fluorine 18 decays to a nuclide of oxygen according to the equation which is shown, my dear students. What is tracer? Again, the same sentences. Radioactive substance introduced into body and absorbed by tissues to be studied. Okay. This is state the symbol of the particle that is represented by X and the values of P, Q, R. Okay. You just need to balance. Of course, they say it is used in the as a tracer in positron emission. So of course, this is what positron, the X, yeah. So if X is positron, which is beta positive, so it has to be what? 0, 1. Balance the equation. So R will be same, yes, 18. So everything is here. Yalla. First of all, symbol X. This symbol, like a beta, but beta positive, right? So P is the down, which is 1. And Q is the up, which is 0. And now when you balance, the R is 18. Make sense? Easy to understand? How the radioactive decay of fluorine results in the PET of the body that are detected. Now here a little previous question was about how they emit the gamma. Here they are talking about in the emission of the body, the gamma ray photons that are detected during the PET. So you need to talk about detection as well. No, only emission. How the radioactive decay results in the emission. So same what you wrote previously. The positron interacts with the electron. The mass of particles changes into energy, which is emitted as pair of gamma ray photons in opposite direction. Write exactly the same. Yalla, write it. So positrons interact with the electrons in the cells. Annihilation process takes place. The mass of the two particles changes into energy, which is emitted as pair of gamma ray photons. Right? That excellent. Right. Now, how the detection of gamma ray photon is used to produce means they are emitted, they are detected. After detection, how it will help you to produce image and examine. So it is only their arrival time and intensity. Okay. So arrival time of gamma rays is measured and examined. Yes, processed. By the way, the arrival time is also used same in the ultrasound scan. I'm just telling you. Over there, we use another term called relaxation time to produce ultrasound image. So anyhow, arrival time of gamma ray photons is measured and processed. This arrival time, it helps to build up the image. Yeah. So this helps to make image of part where most tracer is absorbed or built up. Why? Last lesson, if you remember, I told you the cancerous cell or mutated cells, they have very high metabolism. When they have very high metabolism, they absorb more tracer. Yes? So when they absorb more tracer, so their tracer concentration tells you what? The cancerous part. So that image is obtained, my dear. What is this? I can't read. Half-life of fluorine 18 is T. A patient is injected with amount of substance N of fluorine. Yeah? 18. Determine an expression for initial value of R naught of the rate of production of gamma rays by the tracer in terms of N. N is the amount, which is in moles, right? T is the half-life. N is Avogadro's number. So yes, my dear students, can you tell me first of all the two equations involving lambda? Okay, A is equals to lambda n and ln 2 over capital T, my dear. Now, my dear students, this is going to help you uh, in terms of n and r. So first of all, let's find n. If you go back to your thermal physics, you studied the total number of particles of any substance is number of moles times Avogadro's number. Yes? So from here, the n will be n into Na. They want in these terms, yani, not me. Yani. They told you, yes? So now, my dear students, the activity, instead of activity, they are using R. R, yes? And lambda is log 2 over T. And n you have, can we substitute, my dear? So activity, it will be R naught. Lambda is log 2 over T times n is n Na. Now, my dear, this n is actually decay of one fluorine. Decay of one fluorine gives you what? One beta. And one beta gives you two gamma. One fluorine gives what? One positron. And one positron gives you what? Two photons. So you have to multiply this by 2. Why did I multiply by 2, my dear students? Because n will be not n into na, actually it will be 2 times n into na. Hala, simplify and write the answer. Into log 2, my dear. Actually, we wrote the normal equation of activity, but we just replaced the lambda and n. Multiply by 2 is because they need for gamma ray photons. So each nucleus gives you one positron, and each positron causes emission of 2 gamma ray photons. That's it. Last question, my dear. My dear students, I'm not lazy. And since I will write, you will also write. So they want the definition of a tracer. So tracer is radioactive substance introduced into body, absorbed by the tissues to be studied. Right, my dear students. State the name of the particles that are emitted from the body and detected by detectors during PET. Yes, at least you know them. Gamma ray photons. No, they want the name, not the symbol. How they are created, how the party. I will also write, you will also write. Yes, my dear students. By the way, did they mention anywhere positron? So start from that word first, okay? Positron are emitted by tracer in body. My dear, we all will write. No one will be lazy, my dear. Positrons are emitted by tracer in the body. Then these positrons interact with electrons in the cells. Annihilation process takes place. Mass of the two particles changes into energy, which is emitted as pair of. Read the next part, my dear students. The positrons can be artificially created by process in laboratory that is the reverse of process of B. Means, actually, we don't have this topic which I'm going to mention in our A-level physics is called pair production. So reverse process of annihilation. Yeah, like two gamma ray photons could be used to produce positron and electron pair. Yeah. So anyhow, reverse process creates both positron and electron moving at same speed in opposite direction. Why the two particles are needed to create one positron? Same. Last time we had a similar concept. Yes or no? Because you know that the electron and the positron, they have same mass. They have same mass, yes, and they move in opposite direction. So their momentum is also same. So resultant momentum and total momentum is 0. So it means the two gamma ray photons should all the gamma ray photons should also have zero momentum, and it is only possible when they are pair, yani opposite directions, my dear. Yes or no? So since electron and positron have same mass. So same mass mean what? The combined momentum is zero. So their combined momentum is zero. Combined momentum zero means what? Photons also have momentum. Momentum of photon is there. I don't know. Last time I told you E is equal to PC. So P is the momentum. Photons also have momentum. For momentum to be zero, there must be two photons in opposite direction. Thank you very much. These are the only so far 4 questions we are done. And with that, one specific part of the medical physics we are done, which is PET scan. The rest, other two, we will study them once we finish quantum physics. They will be our last topics because the X-rays, their production, their behavior, a lot of things is in quantum physics. So we will study them in next term.